All right, so you are officially welcome to another PLD discussion, and in today's session we are discussing pointers or function pointers, function pointers, sorry, or pointers to functions. Okay, and basically it's not really a new concept. It's just rebuilding up on something we know already. Okay, so when it comes to such topics, I like to take your minds back to what you know. Then we'll build up from there, from what you know, and you realize that okay, this is something that we actually know, except that probably the syntax for this particular one is a bit different or not. And when I say we already know, we've talked extensively about pointers. Ever since we were introduced to pointers, almost everything that we do has some reference to pointers in it. So we've actually been dealing with it a lot, except that it's always not easy for one to understand. Kindly give me a second. Let me close this door. I think it's sorry about that. So as I was saying, ever since we got introduced to pointers, we've been using it in almost everything. So it's basically not a new thing to us. But now pointing or creating pointers to functions is what makes it new. Okay, so as I always say, when you are introduced to a concept, the first thing you want to know, or the few questions you want to ask yourself, is what is this concept? So we're interested in knowing when we say function pointers, what exactly are they? Okay, we'll also want to know when do we use them. We are also interested in why at all do we need to know or use them, and how to use them. Okay, so if for nothing at all, we should be interested in getting this information: what it is, when to use it, why to use it, and how to use it. So hopefully by the time we are done with this topic, you should be able to grasp the understanding on how all of these. Okay, so as you know by now, and if you're here and you probably don't know about pointers, or for the sake of the people who will be watching the video on YouTube, we already covered extensively on pointers, and the videos are already available on YouTube, so you can always go back to it to revise. But what we said about pointers is that they are special variables that keep addresses. So variables. The values in these variables are what? Addresses. And we've talked about how can we call something an address. So that's the memory location of storage, where that thing is being stored, is known as its address. So if we create a variable, and that variable, what is storing, or what we assign to the variable, is an address to a specific thing, then we say it is a pointer. So if we are looking at function pointer, then basically we are looking at a variable storing storing address to a function. Storing an address, but the address is that of a function. Okay, so as I said, let's go back to our previous knowledge, what we already know. We know about how do you call it? We know about normal pointers. So if we have a variable, say uh, int x, int x. Once we declare this int x, and the program is compiled and we're about to run it, this int s will be stored in the memory of our computer. And as I said, we've talked extensively about that, so I wouldn't go much into it. But we can create a special variable also to store the address. What is the location of X? And in doing that, we use this asterisk to indicate that whatever we are coming to write is a name of a pointer. Okay, that's a special variable. So I usually prefer to preface my pointer names with pt just to identify them. So I can say int int asterisk ptx. Okay, then I would assign this to the address of X so that I know that this PTS contains the address of X. So I can say it's equal to address of X. Okay, so this is what we already know. And by now, I hope that you know the reason why we use pointers. One is that when we are passing variables to functions, or when we are passing parameters to functions, or technically call it arguments. When we are passing arguments to the functions, we prefer to pass the actual values and not just a copy of it. And when you send the name of the variable in your function, it actually creates a copy and not the actual value. So if you ever want to operate on the actual value, then you should go in with the pointer. Okay, so that is one very important reason why we use pointers. There are other reasons why, which when you check the lesson on pointers, you will discover for yourself. But for the purposes of today's lesson, let's hook on the importance being when we are passing a value or a parameter to a function, we need to use a pointer because it helps us get access to the actual thing. It doesn't just create a copy of it. Okay, so that has been said. Here, we know that this our pointer was pointing to this variable. Then now we are talking about not just pointers to variables, but pointers to functions. So we'd also have to appreciate what functions are. And we have learned that a function, so that also we have videos on. So if you don't know them, then you just have to go watch those lessons. A function in C is declared this way. We have the return data type. That's the first thing that you write. In this particular function, what are you or what type of data are you going to return? So that's the very first part. Then the name of the function followed by a parenthesis, then the arguments that we are going to pass. Okay, so basically that's how the function is written. So if I want to create a function, say sum, and this function is going to return the sum of two numbers that I passed to it, then since I know that the numbers that is going to return is, or the number that is going to return is an integer, I can go ahead and do int, then call my function name, which is sum, then say I'm going to be passing you two integers, so int x and int y. This is how we write the function. This is how we write a function. So that is, I mean, I would have called, we'll call this the prototype of the function, but to declare the function itself or to write the definition of the function itself, you have the curly brackets, then the body of the function goes here. But our interest is in the prototype of the function, this part. Okay. So this is how a function looks like. I'm going back to the basics so that immediately I start talking about the concept itself, you don't freak out. Like these things all should make sense. Okay, so I've taken you through how we get the pointers for normal variables. Then now you need to also understand what is it? What a function actually is. So this is the how a function is presented in C. The return data type, the name of the function, and the argument that that function is going to take. Another important thing that you need to know, so we are still building on so that you get the concept. Another important thing that we need to know is how the memory layout in a program, okay, when we run our programs, how is the memory utilized? That is also something we need to appreciate. And the fact is that we have different, like, the actual memory, in our case, the RAM of your computer is divided, right? It's divided into parts, okay? That is for the storage purposes. We have different segments. So we have different segments. And we have actually talked about this in our PLD that we had on dynamic memory allocation. I think the very first one, we talked about these ones. And you realize that the first segment down here is known as a test segment. Okay, the test segment. And what happens in the test segment is that the codes are kept there. Codes are kept in the test segment. So that is the part of the segment that is kept. Then if you recall, whenever you invoke a function, unless if you are doing something inside a function that you have called for the malloc or dynamic, dynamic memory allocation using malloc. Otherwise, majority of the things that you do, the variables that you use will be stored in this part, the stack memory. So we have the stack, we have the heap. Okay. If you don't understand these things, just go back to the video and go and learn them. But for now, I just want to show you something. So ordinarily, when we have created this int s in any function or inside the main function, it's going to be stored inside the stack memory, and an address will be assigned to it since it's taking up a space in memory. But for our function is just a code, okay? So it's going to be part of the code that we write, and therefore it's going to be stored in here. Remember that unlike variables that carry values, functions are just tests that are there. We are not assigning, like, they don't hold values. The function itself, as you have defined, until you call it, the function doesn't hold any value. So it is part of the code that you have written, and is going to be found in here, this part, okay, the test segment. So if you are creating a pointer to a function, what we are referring to as function pointer, then it means the address that will be pointing to is within this space. Within this space is an important thing to note, okay? I'm going to say something after, so let's note that. Unlike all the other things we've talked about, the linked list, we've not talked about linked list here, but I mean, those of us doing ALX have attempted linked lists, arrays, tracks, and things that we talk about, you being able to allocate space for it and keeping it there. We can't do that with functions. We can't do that with functions because function is just a block of code. So that block of code should be stored inside where the codes are stored. That means that the point I'm making here is that we can't use dynamic memory allocation on functions, okay, or function pointers. So take note of that. We can't use malloc for function pointers. Let me just say this. So we can't use it. Just take note of that fact. Function pointers, it can't be used. And basically, the reason why it can be used is that we know that with dynamic memory allocation or using malloc to allocate space, we do it inside a heap. But here you are being told that functions are stored here inside a test segment. So we actually can't allocate space for it. As soon as you compile your code, it takes up its space, like it has a space in the memory when you are using it. So you don't need to deallocate or allocate space for it. Very important point to note. So that's one difference between this particular pointer, that's function pointers, and every other pointer that you know of. Okay, so why then do we even need to have function pointers if we could use the functions on our own? So why? When we're starting, that's the things that I mentioned. The questions here are what I'm trying to answer right now, one after the other, before we get practical with it. Okay, so when we use function pointers, because the code is stored in the test segment, by using a pointer to it, it helps us reduce redundancy. So we don't just copy and paste codes. We have the code already there. So if we need it, let's just make reference to it. Anytime you are using pointers, you are calling by reference. Okay, that's what it means. You are calling by reference. So instead of creating a duplicate copy of our function, we are actually just referencing the one that we have. So if we use function pointers, we reduce redundancy in our code. I hope that's how they spell it. Redundancy. Okay, hopefully. So by creating function pointers, we make reference to the functions that we have already defined. And at any point in time when we call it, we get access to the function. We don't have to create duplicate copies of it and probably bug down our code or program, slow it down or whatever. We have one part of it. The code is there. Once I know that, oh, this function performs this rule, anytime I need to do something somewhere, let me just call it so that I'll be able to use it. Yes, and this becomes practical in the case where we need to pass a function as an argument to another function. So back here, I mentioned the importance of using pointers. So this is a normal integer variable. And I said that when you are passing it as an argument to any function at all, it's preferred that you use the pointer because then you get the actual value. You are passing it by reference, so you get the actual value and not just create a copy of it to work on. Okay, so that is exactly what is happening there. But in our case, if we need this argument of a function, if the argument of a function is actually a function, how will we be able to do that? That's the question. We recommend that for every other thing that we've talked about, once you are passing it via a function as an argument, you are passing it to a function as an argument, it is preferred that you use the pointer so that you get the actual value or you reference it and not create a copy of it. So in the same way, there are times that you want to pass one function as an argument to the other function. So that is when you hear something like callback function. When one function calls the other. Okay, so here, when you pass one function as an argument to another, then we are dealing with callback functions. But we can't just pass the function. That is not going to work. We have to pass a pointer to that function. So that's function. So as we learned, if you just pass a normal variable to a function, we have a duplicate created and we use it. If we pass just the function, what we expect is that a duplicate of it would have been created. But I think even the compilers will not permit you to pass just a function. So for that matter, you have to pass a pointer to that function. So that is one of the importance of function pointers or pointer to a function. That's one of the major importance. Anytime you need to use one function as the argument to the other, you need a function pointer. You can't do it with a raw function. There is another thing too that makes this important, this concept important, and that is when we want to use array of functions. Okay, so there are times that we may want to have a number of functions that we probably use any one of them based on a specific condition. Okay, so array of functions. We use a particular one based on like a condition. So what this actually can help us do is that you realize that sometimes we use a lot of if, else, if statements. Sometimes, depending on the program you are writing, you may end up using a lot of these. And it's also recommended that when you get a lot of them, to make it neater, you can use the switch case statements. Okay. But even with that, sometimes you get a lot of these. But each condition is going to run a specific function if you have a case like that. So I will illustrate all of these, but now I want to focus on explaining the concept for you to understand the concepts, and afterwards we'll look at the practicality of them. So let me assume that we have a switch case here. Switch case, let's say we are checking for something. Let me say X here. We are checking for X. Then inside X, case 1 is if X is 0. You should call probably a function called let me use the basic examples will be these ones, and we will use that as our practical. So let's say we have two variables that is being passed to this, but if, or let me even use a character, say if the person typed a plus, we want to add. If the person typed a minus, okay, then we want to subtract. If the person typed a this. So you realize that we can use switch case statement to do all this and get a particular function run at any point in time. That's what we are saying here is we could be asking, what do you want to do with the numbers that we have here? Are you going to add? If add, just press your add sign. So in creating a simple calculator program, that will come in handy, and you can use the switch case statement to do that, so that if the person press plus, then you are going to be invoking the add function. If it was minus, you invoke the subtract, multiply, divide, modulo, and any other operator that you want to make room for. But in order to avoid all of these and simplify our code, we can also use array of functions. And that is only possible with the help of pointers to the various functions, pointers to the function. So relax. We are going to look at it and you would appreciate it. But now get the concept. Otherwise. Hi, Joe. Okay. So we are still trying to answer these questions, okay? Have them in mind. Every time you are learning a new concept, make sure you have these. So the more practical part will be how to use them. But now we are tackling what is it, when to use it, and why we use it. And that's what we've basically been talking about. So using function to pointers help us reduce redundancy in our program. It is effective when we are doing creating a callback function or passing one function as an argument to the other function. Then it is also the way forward when we want to use array of functions. And these ones, the practical sense is what I illustrated. When you want to replace a lot of if, else, if statements or switch case statements, you can easily do that using an array of function pointers. So we are going to be taking a look at those two things. Abraham, are you saying something? Otherwise, you have to stay muted. Okay, thank you. All right, so we are going to be looking at those two things. Passing, that's for the practical aspects, okay? So anytime you hear function pointers, those are the two aspects that you're probably looking at, especially when it is in C programming. Outside C, there are a number of other uses. Even in C, probably there could be other uses, but these are the two that I am familiar with and are common that I've come across. So passing a function to another function as an argument, passing a function as an argument. So that will be the first thing that we'll look at. Then the second thing we'll look at is passing a function. Oh, sorry. So the second thing will be array of functions, like using array of functions. Okay. So before the start of today's session, I sat down to write a simple program that we can use for this illustration in order to reduce the time that we spend here. Okay, so let's take the first example, which is the callback function, or passing a function to another function. Okay, so the example that I'm going to use, and that is where I will explain all of this. So currently we are tackling this. That's example 1. We are tackling this, and what the example I use is that if you've been asked to calculate the average of, say, two numbers or any set of numbers, you know that to be able to calculate the average, the first thing you need to do is to find the sum of all the numbers that you've been provided. Then after finding the sum, you are going to divide by the total number that you were provided with to get the average. So in our case, the first thing we want to do is let's create a separate function called sum. Okay, and what sum does is that it adds up the numbers that we are given. Once sum adds up the numbers that we are given, we can then pass sum as a parameter, a formal parameter, to average, which is also going to be another function. Then inside average, sum is going to add up the numbers. Then we will divide sum by, the value we get from sum by the total number of numbers that were passed. Okay, so what we are interested in here and why we are talking about it under this topic is the fact that we are going to be passing sum as an argument to average. Okay, so that is the example that is illustrated here. So I said two functions, sum and average. To calculate the average of two given numbers, the numbers have to be summed and divided by 2, which I think is obvious. So here we are using just two numbers. So assuming you are given two numbers, calculate the average. Hence, when the average function is called, it takes up the sum. Okay, it takes up the sum function as a parameter. When you call the average function, it takes up the sum function as the sum function as a parameter. Okay, so the first thing, let's look at how we represent a pointer function. Then we'll solve that case. If I write int x and I want to create a pointer to int s, what do? I do int pointer to maybe any name that I'm giving it. Okay, I do something like this. So that's just like the declaration, how we declare this is an integer pointer or pointer to an integer. That's all I want to illustrate it. A pointer to an integer. That is how it is illustrated. Okay, now let's see if we have a function sum, and if sum returns an integer and sum takes in two argument, say int x, comma, int y. How then do we create a pointer to this function? Using the idea from here. That's why I said these are no new things. They are things that we have already done. So we can easily build on our previous knowledge. When we had int x, for us to create a pointer to it, we just wrote the same thing here. So in this our case, we write the same thing here, which is int. Then we write this pointer, sign the asterisk symbol. So we have the asterisk. Then the name of the pointer that we are going to use. So assuming I want to call my pointer Sam. But you realize that here, the nature of this is a bit different. That means that we have to go ahead and introduce these ones as well. Okay, so we tell it that, hey, this is a pointer to a function with the help of these parentheses. Because if I wrote, instead of this, if I wrote int sum without the parentheses, what does it tell you? It tells you that I only have a normal variable, which is an integer. That's basically it. But as soon as I do this, then I'm saying that this is a function, okay? So int that means that this is a function and is returning an integer. Okay, so similarly, we can't just write, even though here we wrote just the name because it doesn't carry any other thing. So similarly, when we are writing the name of or the pointer to a function, we have to indicate that it is a function with the help of this. Okay, and this specific function, sum, that we're going to point to is carrying some argument. There are two arguments, and both of those arguments are integers. So you have to indicate that in here, integers. This would have been, or this is actually like the way or how it should be done, except that there is one challenge that the compilers face when you write it like this. So we have to address that challenge. What is that challenge? The challenge is that once you have written int pointer, then this, as you have here, this part, just this part, is a notation for a function. So in essence, what your compiler is saying is that you have a function called ptsum that takes into integers, okay, and it returns a pointer to an integer. So it's seeing this as the return data type. Don't forget the format. That's why I started by telling you how a function looks like. So a function looks like this. There is a return data type, there is the name, and there is the argument. That is how a function looks like. So your compiler, on seeing something like this, thinks that, oh, this is the return data type, because we could actually return a pointer to anything. We can return a pointer to an integer. So once you've written it this way, it means that you actually going to create a function called ptsum that takes two parameters and returns a pointer to an integer. For that matter, we don't leave it just like that. We have to make sure that we forcefully tell our compiler that this is a pointer to the function. So this is how we do that. It looks a bit strange, but it makes good sense. Okay, so just by putting a bracket here, you are now telling us that this asterisk here has nothing to do with this integer. So this is actually a function, a pointer to a function that returns an integer, not the other way as we expressed it earlier. So let's look at two things. Write two different functions. If we let's say if we want to write a function, let's say a function that returns a pointer to an integer. If I ask you to write the prototype of a function that returns a pointer to an integer, let's say that function is called, let's give it a name. What will we call it? Anyway, calculate. Let's just use anything. Say the function is called calculate. If you want to write a prototype for a function that returns a pointer to an integer, the first thing is pointer to an integer. That's what you're interested in. So this is it. Then you go ahead and write the name of the function. So this function is called calculate. Then the parentheses, whatever argument that you are going to pass to it. That is how the syntax for a function that returns a pointer to an integer is. Now, if you are to write a function pointer, it's going to look similar, just as in the case of the sum function. We had the sum function was defined as such, okay, int x, int y. It was defined as such. So to create a pointer to it, we needed to introduce the pointer sign, which is this, then pass a name to that pointer or a name for the pointer. So I will call it pt sum. Then we need to indicate that it is a function by introducing the parentheses with the expected data types for the various arguments it's going to take. This is how it's going to be. If you were the person who came to meet these two and no one informed you that one is a pointer to a function and the other is how is it called? Is a function that returns a pointer to an integer, will you be able to distinguish them? Because this we could have called it anyway. I prefer to preface the PT. We could have also called this calculate. Okay, so assuming that we called this our pointer calculate, what is the difference between this? And assuming this takes an integer and an integer, how will you be able to differentiate this from this? That is where the compiler has an issue. So it is, when you do it this way, it sees it as my return data type is an integer or pointer, or a pointer to an integer. So to force us to know that this is a pointer to a function, then we need to put this part into brackets. So we know that, oh, it's actually pointing to a function, but that function returns just an integer, not a pointer to an integer. I hope that is clear. So this is how we do the declaration for a pointer to a function. That is how we do the declaration for a pointer to a function. This is how we declare a pointer to a normal integer variable. Okay, and this is how we declare a pointer to a function. And we are going to see how we use this in the practical case.
Sorry.
Yeah.
Sorry. Please draw back to that that thing you showed me again. I want to see what you. I want you to help me. No, not that the other one. Go back a bit. Backward.
Back
no, not here.
or forward? Backward.
Forward. Yeah. Yeah. Forward. No, forward, please. Forward again. All right.
This is the last line.
The one by the left. Please come back again. How did you describe it? I want to get it very clear. Say
this function. No, this function calculates.
Okay, I know that one, but the other one that you have to
this
brackets. Yes.
This.
How did you say it is?
This, we are creating a pointer to this sum function. A pointer to this sum function. And I've showed that in an example, if we have just int x, if you want to create, we've not assigned though, I'm just showing us the declaration. if you want to create a pointer that will point to X, how to declare it? We do int point, I mean the asterisk sign, then the name of the pointer. We could call it anything, but I usually make it descriptive by using this. Okay, so in the same way, if you have a function like this, sum int X int Y, then we are saying that to create a pointer to this function, the declaration will be int asterisk, just as we did here, then the name that we want to give it. Okay, but in my case, I prefer to call it this. Then the only thing that will show us, you see, this is a normal variable. The only thing that will differentiate this from this and tell us that it's actually pointing to a function is by introducing our parenthesis, and this is taking two arguments which both are integers. So this should be like the way we present it, just as we have done with this normal variable, except that the compiler becomes confused and begins to think that the integer, this goes with the integer. So it's going to interpret this as a function that takes two integers and return a pointer to an integer. In order not to let that happen, we have to tell the compiler that that is not what we are doing here. Our interest is actually creating a pointer to a function. So to be able to do that, we separate this. So this is just to keep this asterisk away from the integer so that the compiler doesn't think it as part of it and say that is the return data type. Do you get
Okay,
it?
so we are calling this a function to a pointer of integer data type.
A pointer to a function. This is a pointer to a function that returns an integer.
Okay. So in the light of this description, if there happens to be it's not possible for it to have another data type right inside the function, right?
What do you mean by that?
What I'm saying is in a situation where you have int x and char y right inside that
Oh
inside
yeah,
this.
you can have, it could be any function at all. You are only creating, this is the return data type of the function. So based on your function, if this was void, this would have been void. If here is char, then this would be char. So it's in respect to the actual function that you are using. We can create a pointer to any function at all. So let me try. Let's say we have a function called, give me any name. So let's create functions here. Then we'll create their pointers here. Okay. So first function, which function do you want to create?
Function type typical.
So you should call the function typical. What is it going to return? What's the return data type of that function?
Return data type is integer.
Okay, so int, then we should call it what? Typical. Is
Yeah,
that it?
yeah.
Okay, so typical. Is it going to take some arguments?
Yes.
What
Uh,
arguments?
the argument is total distance.
So if it's total distance, then are we looking at an integer? Because we need a how do you call it? The
We are
data
looking
type.
at
Are you
we are looking at a
a
float.
float? Okay, so you go ahead and write your floats. Then the name, so probably TD. Okay, so
Okay.
this is the first function. So to create a pointer to this function, ideally the simplest way would be this, and just to tell you that it's a pointer, then PT, in my case, I'll call it PT typical, and introduce this, say floats. Okay, but as I'm saying, the compiler will misinterpret this to be the return type. So to enforce it, I need to put these two in brackets. So this is the pointer to this function. We can assign it afterwards.
Okay. All right. Thank you.
You're welcome. Please, as any other person has a question?
Dr. Obed, well done, sir. Please, I
Thank
want you
you.
to repeat that side, please, because I had a
Which
call.
side?
What you just explained to now, please. A call comes
Okay.
in and my network goes away,
So
please.
you hold on. Give me a function. Just give me a function. Let's work with it. Idris.
Okay. Let us try
What's the return data type of the function?
multiplication.
No, so what type of data are you going to return? Will it be an integer, float?
Yes, it might be any. It might preferably int. I just
Okay, so
want you to
int.
repeat what you just said.
Oh, okay. So let's call the function multiply. Then it's going to take in, say, an integer. So int x and another integer, int y. Okay, so this is a function. If you need to create a pointer that points to this function, then the format is going to be what is the return data type? It's still int. Then this to introduce that we are going to create a pointer.
Okay.
Then in my case, I will call it pt multiply just
Okay.
to simplify it for me. Then there is two integer arguments here, so I have to indicate that int, okay? But I'm saying
Okay.
that the compiler will misinterpret these two. We'll put
Okay.
the int and the asterisk together and term it to be your return data type. So to
Okay.
prevent that from happening, you just put your brackets this way.
Okay. 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 Hmm. I understand.
Okay,
I understand.
so
Thank you.
that you're welcome. So hopefully with these two examples, everyone should probably understand it. This is not any new thing that we are doing. This is just like me saying, not a function, but saying int x. Maybe because I keep using int, I should start using different data type. But int s, if I want to create a pointer that will point us to int s, I do int, then I bring the asterisk. Then the name that I want to give it. So the name in my case, I'll call it PTX. Simple. I've created it. So it's the same thing. If you have a function, this is how the function looks like. So just copy the function and put the asterisk in the middle. But you are not done because your compiler may be confused at that point. Just put first the name of the pointer that you have created together with the asterisk sign. Once you force them together, then your computer now understands, or your program now understands that you are actually creating a pointer to a function. So this is the declaration part. This is how you declare a pointer. Now when it comes to assignments, that's the next thing.
Hello, Doc.
So hi,
Sorry, sorry for this
sure,
interruption.
go ahead.
That int on the right hand side, that int s, that int you put on the right hand side. Is it possible to still put the int s and int y there?
Here,
The right hand side, yes. The
At the
pointer
pointer,
side.
at the pointer side,
Is it
the
possible to put
argument
the int
is
y
talking about
and int
arguments.
s?
yeah, I get a question. I can't say no, I can't say yes because I haven't tried that before. Okay, so the only way is we'll try. We'll just try and we see if it throws an error or not. But this is the ideal way you write it.
Doctor,
Okay. Hi.
this is Akim. Good afternoon.
Oh, okay. Okay. Good
Yeah,
afternoon.
sorry if I may just answer the question the guy just asked.
Okay, sure.
Like for the int, basically when you are declaring a pointer to a function, the bracket, the int, you need to specify the argument the function itself is taking. And instead of supplying the main argument, which is int x or int y, what you are going to supply is the
Mr. Blakim, please
argument.
speak up, please. Speak up, Mr. Blakim.
Okay. So let me leave it here. Right. So basically, what you need to do is like when you are declaring a pointer to a function, it requires that after you declare the pointer itself, in front of it, you need to put the argument type, which the function is going to take. So if the function itself is taking, let's say, int somewhere, then maybe character somewhere, then maybe float something like something like that. You need to indicate it in the exact same step. The function is taking those arguments. You understand? So that's just it. Just like you are declaring a function, but this time you are not actually supplying the argument. You are just supplying the argument type that you need to supply to the function.
Okay. Thank you, bro.
All right.
No problem. All right, thank you. So, hey, where is my all right. I was about to write. We are doing assignment or initializing. Okay, that's what we are about to do. How to assign an element.
Sorry, I don't know if you are going to come back to this, but there was something you mentioned earlier, average
What
and sum. All right. I wanted to see a practical
we
as in
have?
how you
Yes.
include sum and average to combine.
No,
So
don't worry. Don't. We are building this is it. I said we have two practical examples that we are going to walk through. So we haven't done it. Like I'm building up from where we started, okay, so that we can get into it. So the first thing was me showing us how to do the declaration. Then now we are looking at how do you assign values to them, okay, or how do you initialize the pointer that you have created. We need to understand those ones before we can do the practical. So we are going to do it. Then this is functions, okay? So in this column, I'm going to be presenting information on functions. Then on this column, I'm going to be presenting information on regular variables. So if I have int x, say int x is equal to 10, okay? And I'm creating a pointer to int x. I do this int asterisk the name of the pointer, call it ptx. Okay, so this is the declaration that we have done. In the functions example, we are using sum, and sum is taking two integers, int x and y. Then to create a pointer to sum, we have int asterisk sum. Then data types are integer. Okay, just as Hakim explained. Then to enforce this, in order not to get any problems, we bring this our brackets. Good. That's what we've done. But how do we, by just calling this PTS doesn't mean you have assigned it to this. And by just calling this sum, I should have even called it PT sum. By just calling this PT sum doesn't mean you've assigned it to this. You need to go the extra step to assign it. So in this our case, we'll say PTS is equal to what? Address of X. That's we know already how we assign pointers to variables. This is how we go about it. So for our function, will it be any different? We know our function name. Our function name is what? PT sum. But it takes two arguments, int is equal to the name of the function, right? What's the name of this function? So it's equal to address of sum. Is there any difference? Here you use address of X, then you pass it or you assign it to the pointer you created. Over here to use address of the name of the function, then you assign it to the pointer you created. Very simple. It's the same thing. So, or it's similar. So if you know how to use pointers with variables, you should then appreciate this. But one nice thing about pointers to function or functions themselves is that the name of the function points us to the first line of code. Remember that I said the function is part of the code, so it's stored in the test memory. So the address we get is a pointer to the very first thing in that function. Okay, that means just like arrays, when we talked about arrays, that means that even using the address of symbol is not necessary, because the name itself leads us to it. Like, I mean, strings. When we dealt with strings, that's what we found. The name itself points us to the function. So the name itself is like a pointer. So without it, it's still going to work. That means I can rewrite this as ptsum int is equal to sum. Okay, so this can be written this way without the address of symbol. So you choose what you want to work with. If you feel that by leaving out the address of sign, you may end up getting confused along the line, then you can stick with always bringing the address of sign just to tell you that, oh, this is address of sum. But if you always remember that the name of a function is actually a pointer, for that matter, I don't need to use the address of symbol, then you can leave it as such. So these are the two.
This in this one by the rights, I'm trying to understand. You're saying, yeah, this is a pointer to sum, right? So this sum is an address. But I think, how do some cases, can it be a value rather than an address? I mean, can't it be mistaken for a value when with this assignment how it's written down? Couldn't it be mistaken for a value rather than an address?
Why will it be mistaken for a value? If it is a name of a function, what I'm saying is, if it's a name of a function, that's how the computer sees it. The moment the computer sees sum in your program, it actually goes directly into where the code is. So once you've already declared that sum is a function, at the site of sum, the compiler understands that this, like the actual value in here, sum. So if you print out sum is like an address value that we have been seeing, hexadecimal. So it is not you, the individual, who is going to interpret it and now say that, hey, this could be a value. It's the compiler. So you, the individual, have to know that whenever you use the name of a function, it is actually an address. So you can go ahead to use it without the address of sign. That's why I ended by saying that if you think this notation will confuse you without the address of symbol, then you stick to this. Always go with your address of symbol, but it doesn't make it wrong. This is also right. So either this way or that way, you choose the one you are comfortable with, but the compiler is not going to make that mistake. I hope you are answered.
Thank you.
You're welcome. Okay, so now back to our program. We are here. Obviously,
sorry,
please,
can I ask a question?
Yeah, sure.
Yeah, okay. So in that function, please, can you please go back?
Okay. This place.
Yeah. So now, what if you assign this function as in the second part as a right hand part? What if you assign that function to a variable? Yeah, if you assign that function to a variable, can you use a pointer to actually point to that variable?
What do you mean by you assign the function to a variable?
Now, the function of sum, right? The function of sum, can you assign it to a variable, like store it in a variable, so that you can then use the pointer to call that variable?
No, like an ordinary variable, say x is equal to sum.
Yeah.
Right. No, I don't think so. If you do x is equal to, then you pass, let's say, the values. You pass the values this, and probably this would be the return value that will be pushed here. That would be the return value. It wouldn't be the address of sum. If you want to pick the address, then it has to be a pointer that is being assigned, like it's being assigned to the pointer. Okay, so I don't think you should, like, you can just go and say x is equal to sum. No. I haven't tried it. I like learning by trying this, so you can equally try it.
All right, thank you.
Welcome. Okay. So just for the sake of those who join late, this is a program that we are trying to practicalize the knowledge we've obtained so far. So the concept here is using callback functions or passing one function as an argument to another function. So we have two functions that we are going to work on right now. We have the sum function and the average function. Maybe I should the time to it. Okay, let me just walk us through the sum function and the average function. And to calculate average of a given set of numbers, we need to first calculate the sum. So we are going to pass the sum as a function, as an argument to the average function. And that's how we go about it. So basically, we are using the stdio header file just to help us have access to printf, okay, to be able to display something on the screen. Then this is the prototype for the sum function. This is a prototype for the sum function. The sum function is what? Sum int x int y. Very simple. And this is a prototype for the average function. And that is where it usually confuses some people, but it shouldn't confuse you. So let's see what these two are about. Let me try and explain it. So we have in sum taking in x and what? Int y, okay? So int y. Then we are creating a pointer to it. We are calling the pointer this PTF. This is a pointer, okay? Int. That's what we are trying to do here, but we are forcing this here. Good. Now we need to pass sum to average as a function. So average also being a function would have been defined as int, which is the return data type average, okay? Then the argument that is going to take. But remember that I said if you are passing a function as an argument to another function, you don't use the function itself, you use the pointer to the function. I hope you remember that. You use the pointer to the function and not just the function itself. So that is exactly what we are doing here. Say, and you won't go there, but let me write a new one. You have created, this is essentially the pointer. You have created a pointer. That is after you have assigned it. So I would have gone forward to say PTF and is equal to sum, okay? Or those of you prefer to use the address of sum. So now that we have this, we can then go ahead and pass the pointer here, say PTF int. I don't think it should be strange anymore because you are just writing the prototype that you created here. That is what you are writing in the average as an argument, so that this function knows that you are pointing to this particular function. I hope it's not looking strange. That's why we took it step by step. You have created, by now you know how to create this, okay? So all that you need to do is for the function that you want to pass this particular function or this specific function as an argument to, just copy the prototype that you created there and put it in the parentheses for the function. Okay, so I'm just moving this here. That is all. But that is like just the first part. So that's like sum. So ideally it's something like this. It's something like this. Sum. Okay, but we couldn't just write sum like this. So you know that this is a function. Then any other parameters. So in our case, we pass extra parameters, int a and y, b. Okay, but we can't just write sum here like that. We have to write it as a pointer. So we bring all of this here. Simple like that. I hope it is simple and not confusing. So that is what you are seeing here. Okay, this let me see. Okay, so sorry, when you look here, this that you have here is just a pointer that was declared that will be pointing to some. In fact, it can be pointing to any function, but we are going to assign it to some along the line. Okay, so that is what we have here. But this is just the prototype for the average function. This is just the prototype for the average function. That means that we should probably find the definition itself. So let's go down, see the definition. So this is sum, the function for sum here. I hope you can see it, and I hope it's not too small. Oh. Okay, so there's a definition for sum. What is it doing? Sum takes in two integers, then just return the sum of them. X plus y. This by now you understand this whole thing, so I shouldn't bother myself. Just taking two parameters and adding them up. Now we want to pass sum as what? As a parameter or an argument to the average function. So we bring the prototype for the pointer that we declared in here. Simple like that. So I've explained this. That's why you have it here. Then this average function is taking two separate integers. Those will be the integers that we are going to be adding. So the next thing is, how do we use it? How do we call? So in this particular case, we are calling the function. We are calling the function. Okay, that's what we are doing here. We are calling the function, and I'll explain it soon. Once we have created it this way, we can go ahead and just use this. Okay, you can just go ahead and use it. Some people will say that you should put an asterisk before this so that we dereference it, but that is also not necessary. The compilers understand once you are using it, they understand. When you use this, it goes directly there and go and pick. Then you are going to apply A and B. So what is happening here, unless we go into the main also. So maybe I should just walk through the whole code, then we try implementing it ourselves so that you understand. Okay, so when you come inside the main, that is where the assignment is taking place. We are assigning a pointer, okay? We are assigning a pointer called PT sum. And this structure here shouldn't be any new thing to you because that's what we have discussed here. We've discussed here, okay? That's the same thing here. And assigning it over here. Okay, so basically that's what we have here. In fact, you all know that here, maybe I didn't do it, but if you do int x, okay, it's equal to say 10. You have something like this, and you are creating a pointer to int x. You can go ahead and do this pt x and assign it to address of x. So address of x, okay, that is allowed. So that's what we are doing there. We know that our sum function is like this, so we are calling this pt sum. Then it's going to take two integers, okay, then we are assigning it to address of sum. But I said you can ignore the address of because sum is also like an address. It points you to the code, so we don't need it. That's why we have this line of code here. Please make sense out of it. This we've already discussed, and this is just assigning it to sum. We have created the sum. Now we are calling this our function. As we all know, you can call functions with their name and providing the values to them. Okay, so average is being called, but average, the first parameter or the first argument in average should be a pointer to a function, or what we call a function pointer. So PT sum, as you see it here, is a pointer, a function pointer. So we can pass it here. Then we are passing two numbers here, x and 5. Okay. Okay. So any questions on it? Let me try. Let's see. Any questions on it? I don't think we'll be able to do the variadic functions if I should go ahead and do the practicals. Okay, so I'm just trying to launch my how do you call it? My virtual machine, then we test the code there.
Doctor, please, are you not using Vagrant?
No, please.
Please, which one are you using, sir?
I just installed Ubuntu onto the virtual machine. So that's what I use. I think I even shared the guidelines in the group. It's inside the Telegram group. Like there is a PDF on how to do it inside the Telegram group.
Okay, I will go and check it, sir. Thank you, sir.
You're welcome. Why are you hiding? Okay. So the machine is ready now. The advantage of this is that it has a user interface. So I can use it like the ordinary computer and not just the terminal. But for now, let's launch the terminal. Okay. And have the terminal here. See the project. I think I created one for PLD. Okay, CDC programming. Okay, so let's make a directory for what is this? We are doing what? Function pointers. Function pointers PLD. Okay. CD function pointers. Then let's open this code. Okay, let me open. Sticking up. Sorry. When it goes to full screen, I can't see the edges. So let me open this new. Okay, let's open new window. Okay, so let's create a first file and call it what was it? Okay, average.c. Let's call it average.c. Hopefully I can open it like this. Open up. Is that the maximum we can go? Okay. All right, so let's do this. I think I should just go and copy the other one. In order not to spend so much time here, let me copy this. At least the syntax highlighting may simplify things for us. Good. So let's see what's happening here. For the first part, the include parts, I believe everyone understands why we include this. We are going to be using printf, so we need to include it. Then this is the prototype for the various functions that we are writing. So prototypes for functions used. So that is during your ALX tags, usually you keep those prototypes in the separate header file, but in this case, we are putting them in here. Then this is our main function where everything is going to happen, but we are defining two functions outside that. This is the sum function, and this is the average function. Okay, so what average does is that it needs the sum function, okay? It needs a function. So we are going to pass a function to it. Then it's going to operate on these values that are provided in the average function. So how you use them is inside this main. Okay, inside the main, you can see that these are declarations. Let's see. The first declaration here is we creating a pointer and we are assigning it. Okay, so what we've actually done here could have been put in different steps where we could possibly have done this. Say we could have done this before we go and assign, but do not repeat yourself if possible. So I prefer it this way. That is, this is the function pointer. This is the function pointer that you have declared here, and you are assigning it to the function sum. Sum has its definition here, okay? So the compiler will understand. And as I said, you could have put the address of symbol in front of it, but let's take it away for now. Then here, average, as we can see, is going to return, in our case, we want it to return just an integer. So we are going to be careful. It's just a sample code. You can adapt it to return a float, but I want it to return an integer. So the return data type here is int. That's what we have here. And I'm assigning the value that this average is going to return. I'm assigning it to value. Okay. So hopefully you understand what is happening here. Now at the end of the day, I'm now printing value. So let's go ahead and compile the code. Let me first save this. We compile the code. Say GCC average, then pass the output to average. Okay. Good. Now let's run average. It gives us 6. So where is the 6 coming from? The two numbers that we pass here are 8 and 5. 8 plus 5, that is what? 13. 13 divided by 2 would give us 6 point something. But because we are returning an integer, that is why it's giving us 6. So that is correct. Now let's make it something easier. Say 2. So we expect that this average, please, I hope you can see my screen. This one that it looks small to me. I hope it's okay now. Okay. So what's happening here is that when we pass, this is the function we have created, that we are passing it by a pointer. So we are not passing it with just the sum. We are with just the function. We are assigning a pointer to that function and we are passing the pointer. Okay. Then we have these two numbers. So when you come down here, what we have done is this is that pointer we're talking about, and this represents the two numbers. So A is 8 in this specific example, B is 2 in this specific example. So when you come here, we have 8 and 2. So we have PTF of 8 and 2. But PTF is a pointer to what you passed here. What did we pass in the average? We passed PT sum. So it's a pointer to, it's a reference to this pointer. And this pointer is pointing to sum. So it's going to take you back here. Okay, I wish I had that debugger, but let's go on. So sum is now going to operate on 8 here and 2 here. We have 8 plus 2, which will be 10. So sum is going to return 10. And when it returns 10, it means now n is equal to 10, because that's what this expression here is returning. Then this function is going to return 10 over 2, which will be 5. So if we should compile this and run it, it should give us 5. Good. So you can actually adapt this code to do other things or make it more comprehensive. But for now, just to illustrate our point.
Hello, Doc.
Yeah.
What if you change the return type? Maybe to float or something else?
Yeah, if you change it to float, it will print out float. But you have to be mindful that, especially when you are dividing an integer by an integer, will return an integer. So that means that you would have to force your value that you get. You have to force it to a float. So maybe you do typecasting to a float before. So that should be taken into consideration. You can try that. But it's possible. It's totally possible. Okay. Just because I don't want to focus on those nitty-gritties. The concern here is using how we use the function pointer. So in summary, what we have done here is what we call the callback function. One function calling the other. And basically, this is where it happened. We have the average function, and the average function takes a pointer to another function. Okay, so that is what we have been able to establish here. And that's the first importance of function pointers or pointers to functions. Those things usually confuse you. Function pointers. Okay, so that's the first importance that we have looked at. And let's take a look at the second importance. Or any questions on this? This thing. You don't want to go up? Okay. So I mentioned that the second important thing we can do with it is creating an array of functions, then making a decision to use any one of the functions at any point in time. Okay. So that means that to be able to appreciate this, you need to appreciate the concept of functions. You need to appreciate the concept of pointers. Then you need to appreciate the concept of arrays. All of these we have tackled before. That means that we are building on the knowledge that we have. So if you missed any of those lessons, just go back, revise. In fact, one thing that I should say is that you won't always remember like all of these things. For now, your interest should be on understanding them. Okay, so that if 2 months from now you are given such a case or you have a task similar to this and you have forgotten, when you come back to it, you should be able to make sense out of it within a short period. If you don't understand it now, then when you come back to it, you know how to spend forever to understand it. The same amount of time that you are going to spend right now to understand it. So for now, just try and understand it, see how it is implemented. You have to try writing some of them. Okay, some of us, when we watch tutorials and we feel like, oh yeah, I understand. oh yeah, this one I understand. Like you have joined us here and I'm explaining it and you feel like, oh, I understand this. Yes, I understand what you just did. I understand. If you don't try it in your hands, it's a different case. Okay, that's how programming is. So you'd have to also go and try these things in your hand. So going forward, I think last time I created a repo on GitHub to keep our codes in there. So as soon as we are done with this, I'll push this to the repo so that you can always have access to it to test your hands on it, make your changes, try duplicating it and the rest. But you need to get practical with it. And I assure you that at one point in time, you forget some of these things. But it should always be the case that when you come back to it, you can easily learn or remember them. Or when you revise, it wouldn't take you as much time as it would take you if this is the first time you're learning it or you didn't understand it in the first place. So go back to arrays, go back to pointers, go back to functions, just go and refresh your memory on them. If you really did understand them, then it shouldn't be a long, it shouldn't take you long to understand them or revise them. Okay, if you didn't understand them, just go focus on getting the understanding, then you can move on. Okay, always my concern is the understanding. Once you understand it, you can always move on. You are definitely going to forget a lot of the things that we are learning. That is normal. Don't kill yourself when you realize that you've forgotten what you learned. But when you go back to them, how long will it take you to remember? That is the most important thing. Okay, so with the help of this, we are going to create a simple calculator. And for now, just for the purpose of our discussion here, our calculator is going to operate on two given numbers and give us the right answer depending on what the person chose. So earlier on when I was explaining the importance of this, I think back in our slides, I mentioned that we could use a number of switch cases. Yes, here. Use a number of switch cases, then we check for what the user enters. If the user enters X or plus, if the user enters plus, then we know that we are calling the add function. If the user enters minus, we are calling the subtract. If the user enters times, just like that. Okay, so instead of using the switch cases or using the if else if statement, we can equally use array of functions. And I said to be able to use an array of functions, we need to use pointers, okay, or function pointers. So that's what we are going to be doing here. So from the head here, we are calling our this thing. I'm coming. Okay. Or maybe I should start copying it to there. But what we are doing here is obviously you should know this particular one, the header file to enable us to use printf. Then the prototypes for the various functions we are going to be creating. So we are creating add, subtract, multiply, divide. And this shouldn't be new to you because it's basic function declaration or prototypes. Okay, then let's see how we define the functions before any other thing. So we'll come down here, define the functions. Very simple, very, very simple. So add will take in two integers, x and y, then return the sum of them. Subtract will take in two integers and return the subtraction, x minus y, the results. Hello, Jasper. Jasper, are you going to ask a question? Otherwise, you have to stay muted. Okay, sorry for that. So, why have you come? Yeah, so it's similar to the other functions. This is the subtract function, this is the multiply function, this is the divide function. So you can do it for almost all of them. In this specific case, I want each of them to be returning an integer. Okay, each of them to be returning an integer like that. Okay, now this, what we have done, like what I've gone through right now, I believe that we all understand. Like with just this part, just this, then the prototypes, then the definition of the functions. I believe everybody is okay with it. Now let's see, how do we declare a pointer to an array of functions? Okay, that's what we are going to look at. Pointer to an array of functions. Okay, let me use this. We have already seen how we declare a pointer to a function. A pointer to a function is written in this way. Oh, right. Okay. A pointer to a function. So let's use our sum function since we've been playing with it for long now. Int x, int y. Okay. These are sum function. To create a pointer to it, we do what? Int asterisk, then the name of the pointer, call it pt sum. Then we have the data types, int and int. Okay, but we have to enforce this by putting them in brackets. This is how we get what? The pointer to a function. What if we have multiple functions that have this similar nature? What you saw from here, you realize that the functions had a similar nature except the operator that was being used. So they all take in 2 integers and they retain an integer value. Okay, so they have a similar value. So arrays. Arrays are basically what? A collection of elements of the same data types. That's an array. So once we have a number of functions, in our case, we have sum, multiply, divide, and subtract. They all look similar. That means that we can create one pointer, but it will point to all of them. So how do we do that? Okay, basically, let's call that pointer, I am going to call it pointer to all. Okay, let's assume that that is how we are calling it, pointer to all. If we call it pointer to all, then for each of them, what's the data, return data type? That's an integer in our case. Then asterisk to show that it is pointing to something. The name in this case is pt all. All right. Then the data types that is going to be taken, each of them takes 2 integers as arguments, like that. And we've said that you enforce this, okay? But in programming, or let me say in C programming, you know how we show that something is an array? With the square brackets. Hope you remember that. This is how you show that something is an array, the square brackets. For that matter, we would have to make this pt all square brackets. Kindly give me a second. All right, sorry about that. So that's the only new thing that will come in here. It's similar to everything that we have done, except that you'd have to introduce the square brackets in front of the name. Once you introduce the square brackets in front of the name, that tells us that this is a pointer to an array of functions, okay? So it isn't anything new. We've learned all of these, okay? So the only addition here is adding the square bracket in front of the name to tell it that this is a pointer to an array, but the nature there is what? That of a function. So an array of functions. An array of functions that take in 2 arguments of type integer. and returns an integer as the data type integer. I hope it makes sense. This, like when you see this prototype, what it's telling you here is that the notation alone, once you have something like this with a bracket, especially it is this parenthesis that makes the difference. Okay, once you have this parenthesis there, then you know that you are dealing with a function. And this function, we have set a pointer to a function, but this tells us that it's an array of functions. So it's not just one function we are pointing to. We are pointing to a number of them. Okay, so that is the presentation. Then how do we assign values? Let's try a normal integer array. How do we declare that? Let's say scores. You know, this is how you declare scores. Okay, that's how you declare scores. Integer array. And you can assign values to this by doing that and passing the values directly. Say 1, 2, 3. Okay, we can do this. The other way we can assign values if we don't do this is to call each of them using the subscript notation with the help of the indices. So this would be 0 is equal to, say, 1. Then scores 1 is equal to 2. Scores 2 is equal to 3. Okay, so a similar thing can be done for our pointer to array of functions, except that these ones will be equated to functions. Okay, you can go ahead, just as we did here, we can go ahead and just use the curly brackets and pass the name of the functions to it as members of the array. Or we can equally use the notation, the subscript notation, and pass the name of the functions. Okay, so what I'm saying here is, assuming you created a function sum, you have divide, you have multiply, then you have what? Okay, let me use add. We've been using sum for too long. Add, divide, multiply, then subtract. Okay, so assuming this is what we have, what I'm saying is that in the declaration, you could go like this. All these functions return integers. How do we call it? We are calling it PTR. That is by choice. You can call it anything you want. And it's pointing to an array of functions. So this is the notation. And each of them take in 2 integers. So we do it this way. Then now we can go ahead and use the curly brackets notation. See this, what's the first one? First one is add. Second one is divide. Third one is multiply. Fourth one is subtract. Okay, like that. So this is how we can declare and assign together. But just as I illustrated with our normal array of integers, we could also use this notation to do the assignment or initialization. In that case, we would have just done PT or 0 is equal to add, PT or 1 is equal to divide, and the rest. Okay, so basically this is declaration and assignment, and we could also assign using this method. So let's go back to our code and see what is happening here. Okay, so in here, the first line inside the main function, can you even see? Okay, I hope you can see now. The first line inside the main function, what is it doing? This line. Okay, so let's pay attention to this line, this first line. If you can see, this integer here, int here, is just telling us that this is a pointer to a function that returns an integer. Okay, that's what the integer tells us. Then the square bracket here tells us that, okay, this pointer actually is pointing to an array of functions, and each of the functions that we are pointing to take in these sort of parameters, integers, so 2 different integers. That's what they take in. Then we are assigning the values. This is add, subtract, divide, and multiply. Don't forget the concept of arrays. We say that this is at index 0, index 1, index 2, index 3. So when we are later going to use them, we have to keep in mind what index 0 is, what index 1 is, what index 2. We have assigned it, so that is the best way that we are going to present it. And I've showed you another way that you could have assigned it, but this makes your code a bit concise. So I think it's easier to go with it this way. Okay, then over here is just to make the program useful. I'm printing out something, asking the user, what operation do you want to perform? Press 0 for add 1, press 0 for add, 1 for subtract, 2 for divide, 3 for multiply. Okay, then I go ahead and ask you, what do you choose? Then I call scanf. Scanf will let you enter what you choose. So between 0 and 4, 0 and 3. Between 0 to 3, you choose what you want. And depending on what you choose, pay attention here. Depending on what you choose, so whatever you choose, assuming you chose 0, what I'm done here is 0 is going to be stored in choice, okay? And I'm using scanf to do that. And hopefully by now, you know how to use scanf to accept user input and assign the value to an integer. That's exactly what I'm doing here. Okay, so choice now will contain whatever the user enters. So if the user enters 0, we know that 0 is add. So when I call this function, I mean the pointer to the function that results in this. Choice is being passed as the index to the operator. Okay, so these are the functions. In the 0, if the person entered 0, then it means we are calling add. If the person entered 1, we are calling subtract. If the person entered 2 here, we are calling divide. And if the person enters 3 here, we are calling multiply. So this concept is similar to where you were using the plenty switch cases. Okay, but now with basically 1 or 2 lines, we can achieve the same outcome. So here, what we are doing here is case would have been say 0, 1, 2, 3, and depending on what the person chooses, you call a specific function. Okay, but we've been able to condense this into such a program where we just ask, which one do you want to do? So we could have also used, we could as well have used characters, but this will make much more sense. Okay, so what do you choose? If I choose 1, I'm just going to call inside this array of functions. Which one is 1? 1, that's index 1, that is subtract. That means that we are going to subtract 10 from 14. Then at the end of the day, I'm going to print the result. So basically, that's how this program works. Let me copy it to the editor. Then let's try it on the editor.
Doc, please.
Yeah.
Hello. Could you please recapitulate, please?
Come again.
Could you please recapitulate this particular line you just mentioned, please?
Okay, but I think I'm coming to bring it into the code and I'll explain everything right here. Okay.
Better.
All right, so let's create a new file here. A new file. We call this, what are you even doing? Calculator. Okay, so I think it should, okay, calculator, calculator.c. Okay, then let me just quickly copy the code here. copy it, then paste it so that we'll walk through it. Good. The only mystery that we have here right now is just these two lines. So let me comment them out. The rest should be things that we already know. Okay. If you don't know the rest here, then you probably should go and do a lot of revision. Okay, basically what we have done here is these are declarations. Okay, so prototypes for the functions used. Let me pass the comment. Prototypes for functions used. Okay, these are the prototypes for the functions used. Then we come down here to define the functions. So say defining the various functions. The point that we are trying to make with the concept pointer to array of functions is that these functions have a similar nature. Okay, once they have a similar nature, and we know that arrays are a collection of elements of a similar nature or similar data type, it means that we can equally put all of these as arrays. Okay, that's what into an array. Sorry, that's what we have done here. So they all resemble each other. Look at their prototypes. Their prototypes are similar. They return integers. They take in two parameters, which are both integers, and they return an integer. So each of these look like the other, except that the operation inside is different. That means that we can still put them into an array, then use them as and when we want. Okay. So in here, all we are doing, I've commented, so forget about what we've commented out. All we are doing right now is we are printing something to the screen. So here I'm asking, which operation do you want to perform? And I say print 0 for add, 1 for subtract, 2 for divide, 3 for multiply. Hey, I made a mistake here. So 3 for multiply. I hope that was it. And don't forget that these numbers that I'm calling that I'm going to use as index should match with what we assign, how we assign the values in, or how we place the various elements in the array. Okay, so this is just some two print statements that we have here, which we are used to by now, how you print something in C. Then we declare a variable called choice. This variable, after declaring it, we want to pass a value to it, but we want the user to enter the value. So we are using scanf to collect the value. What choice are you making? Is it 0? Is it 1? Is it 2 or 3? So as soon as you enter 1, we put it into choice. So choice will now contain the value that you entered here. Then let's now talk about this first line here. This first line, all we are doing here is that, let me remove this part first. Okay, then let's pay attention to just this line. What are you doing here? Here, which we have already seen when I illustrated it. This is basically a pointer to, because of this square bracket. So in the first place, because of this, we know that we are dealing with a function. So, and in fact, you should be able to break these things and understand them. This here tells you that it is a return data. The return data type is an integer. This one here tells you that it is a function and it takes two parameters, two integer parameters. This here tells you that it is a pointer, like we are dealing with a pointer here. Then this here tells you that we are dealing with an array. So when we put all of these together, please pay attention. When we put all of these together, this is return data type. This is telling us that the arguments are, there are two integers as arguments. Then this is telling us that it is an array. And this is telling us that we have a pointer. Okay, so basically, this is seen as what? A pointer to an array of functions, which take in two integer arguments and returns what? an integer. Let me try and type it out so that you get it. A pointer to an array of functions that takes in 2 integer arguments and returns an integer. Okay, so each of the functions that we are creating, will actually take up 2 integers. They will take up 3 integers, then they will return an integer. So we have a collection of them. That's why we are saying an array of them. And this is what indicates that they are an array. Then this part, the name here, together with the asterisk tells us that it's a pointer. So a pointer to an array of functions that take, so it's a pointer. Anyway, we are not doing English here. That take in 2 integer arguments and returns an integer. I hope that makes sense now. After we've established this, we now need to assign values to this particular pointer to array of functions that we have created. And that we should do it this way. I said that we could have also gone the other way where we use the index to assign them, but this makes the code look concise and cleaner. So I prefer we go with it this way. So here, all that you have done is you have, these are elements of the array, and each of them is identified with its index. So add here is at index 0. Subtract here is at index 1. Divide here is at index 2. And multiply here is at index 3. Then we know that to call any of them, when we pass, say here, over here, I think even when we take the asterisk off, it should work. Yes. So over here, when we call this name together with a square bracket and we put, say, 0, if I put just 0 there, all that I'm saying is that go into this array, okay? The array is called PT operator. So go into this array and look for index 0. What is index 0? Index 0 is add. So essentially what I'm doing is I'm replacing this. This is add. So I'm replacing this with add. That's all I'm doing here. If I did that, if I put 0 here, because 0 is add. If I put 1 here, if it is 1 that I put here, essentially what I'm doing is this, subtract. Okay, this is what I'm doing if I put 1 there. If I put 2 there, then I am replacing this whole thing with what? With divide. So it isn't any new thing. The only thing is that you have just created an array, and the array is made up of functions. And you can use the index of each of them to call it anytime you want. And this is helping us even make a nice program where now, depending on what the user enters, okay, so the user is going to enter something and we are going to pass it here. I should have written code to check that they don't enter more than 3, like from 0 to 1, but that wasn't my concern here, so I didn't bother to look at that. So the only thing I'm doing here is I'm waiting for my user to input a number here, and depending on whether they input 0, 1, 2, 3, I come in here and choose the appropriate function, then operate on the number that they have here. Then I assign the outcome of this, which is supposed to be an integer. The return type is an integer. So the outcome of this is assigned to results. Then I go ahead and print results. So it's that simple. Any questions before we run the program? Okay, let's get the terminal up and running. Now, compile calculator.c. and pass it to calculator. Or let me just do calc. Okay, so let's run calc. And it says, which operation do you want to perform? Press 0 for add, 1 for subtract, 2 for divide, 3 for multiply. What do you choose? So let's choose, say, 3. 3 is for what? Multiply. So we are looking to have 140. So enter. And that gives us 140. So we created a number of functions. In this case, 4 different functions. Their structure is similar, and we've put them into an array. This should make sense. We've put them into an array. Each of them can be identified with an index. So all that we have done here is that depending on the index that you choose, let's use that function. So at any point in time, if you want to use a specific function, you just access it with the index. So let's run the program again, and this time around choose something else. Say 0. 0 will be add. 10 plus 14 will be 24. So it should give us 24. Okay. If you run the program again and choose 2, 2 is what? Subtract. 40 minus 10 is 4. So you should get which one is that one? It's giving us 1. So let's debug our code. Subtract 10 minus 14. Why is it 1?
2 is divide. 2 is divide. 2 is divide.
Okay, sorry. All right, thank you. I see. So 2 is for divide. Oh, I was saying that I know that thing is very confusing sometimes if you don't pay attention to it. Just looking at the elements and say, oh, this is 2 instead of 0, 1. Okay. So let's we've lost what's calc. So let's go with it's 1. 1 will be subtract. So we get 4. And hopefully this makes you understand how to use the pointer to array of functions. Okay. And you see, comparing this to using the switch case or the if else case to do all of these, this looks very simplified. Okay. If you're not too comfortable, you shouldn't kill yourself coming to use it. But at the end of the day, you should understand it, because sometimes you may have to go through people's code to appreciate it, to do something. Okay. And that's the essence of learning some of the things that we may not even end up using. Okay. Any questions? I don't think we can't do the variable. We've gone almost 2 hours. In fact, more than 2 hours. So we can't do the variadic functions. Probably in the course of the week, we'll schedule time for variadic functions. Yes. Any questions before we bring this to an end? I hope. Yes. Any questions? If there are no questions, then we've come to the end of the session. Please status. Ooh. See. I hope. Okay, good. So let me add functions and get commits message since PLD on what is this function pointers. Okay, and get push. Ooh. Okay, so I think I'll have to pull it and do. But anyway, once there's no question, thank you all for joining. I really appreciate your time. Bear with me all these hours, especially because today I didn't make it up on time, but hopefully going forward we would make it up. And variety functions will be next before we probably start thinking about printf function. Okay, So thank you and see you some other time. Bye-bye.
Thanks.
Thank you, sir.
Thank you, and bye.
Thank you very much for your session.